Hi everyone, so we're going to be starting a new section right now. So we're going to be talking about the formation of our solar systems. So we're going to get started on this one. Remember, we're taking our notes in class notebook. So this will be up there with some guided notes for you to take with our information here. Okay, so let's get started right away. So we're talking about the formation of our solar system and other planetary systems. So a little bit of what we're thinking about here. So how many stars are there in a solar system? Was the solar system created as a direct result of the formation of the universe? How long has Earth existed? Is Pluto always the farthest planet from the sun? What typical shapes do moons have? And have any Earth-like planets have been discovered orbiting sun-like stars? So another thing that we're going to be talking about is how solar systems are formed, why the environment of early solar systems were much violent than it is today, how are the planets grouped, how astronomers characterize each planet's personality, how the moons through the solar system are formed, what the debris of the solar system are made of, that planets have been observed around a growing number of stars, and that newly forming star and planet systems are being observed. Okay, so jumping right in. So what we know about right now is that the lightest and simplest elements are helium and hydrogen. So these are the simplest elements that we talked about here. And when that Big Bang happened, these were the most abundant in the environment, and they continue to be the most abundant in the universe. But heavier elements such as iron and silicon are created by thermonuclear reactions in the interiors of stars. And that's where we're going to kind of focus over here today. And then they get injected into space, which is where we get these new elements here. So the great clouds of gas and dust ejected from old stars are what are going to be made into new stars. So you can see here, this is going to be Orion. So if you've heard of that constellation before, the belt of Orion, you can see those 3 stars here. But those new stars are still surrounded by the nebula by which they were created. So when those stars die, the old stars die, you can use those gases and information that they had to make those new stars. So we're talking about solar system formation. So we heard a little bit about this in our video. So when the creation of the universe, so we had that big explosion and it moves forward and forward until we start cooling here. And then we can get really distinct different planets and stars from this. So formation of our solar system, really important here, this slide we're going to talk about. So our solar system begins from a gas cloud that collapses in our center due to gravity. So the influence of gravity has our collapse here, and the condensation forms at the center, and this is going to be called our protostar. So right here, this is our protostar. And then as we continue to go through, we see that flattened disk began to shine around that protostar. So that's how we're starting to make this. So we collapse in on ourselves, we create that protostar, that center of that system. So for us, that is our sun. And then that matter around it begins to shine and create other things here. So the rising temperature from the sun removes gas from the inner regions, leaving dust and larger debris here. So it removes the gas closest to the sun. So if this is our sun right here, we're removing the gas that is surrounding it over here. and just leaving that dust and larger debris. So planets establish dominance in our regions of the solar system. So we're going to start seeing those planetary creations over here. And after most of the remaining dust and smaller debris has been collected by those larger planets creating and coming closer together, the solar system takes on the form that we would recognize more today. So if we look at this bottom picture right here, we can kind of see this is what we are expecting to see in personally our solar system, but also that's what we expect other solar systems to look like as well. So if we're thinking about our list of ingredients in our solar system, our sun is going to have the most mass in our whole system. In our specific system too, Jupiter takes up a little bit more than our other planets here. But again, it is still only 0.1% of the total mass in our solar system goes to Jupiter. 0.05% goes to our other planets, so the other 7 planets in our solar system, and then another 0.05% goes to everything else, so asteroids, comets, etc. So 99.8% of all of the total ingredients in our solar system is going to go to our sun. So that's important to note, that most of our mass here is in the sun. Okay, and just talking a little bit about other star systems forming. So we can look at young star systems that are starting to develop today, and you can kind of see that that is how we created our solar system here. So the planets orbiting these stars are formed by surrounding disks of gas and dust. That should sound familiar. And those are creating protoplanetary disks or proflids. So that is what is kind of the starting. So the other starting of star systems here, which is important to notice in the comparison here. Okay? So we are going to stop here for this time. Make sure that we are taking our notes in our class notebook. Okay, and I will see you next time.